Oh. Take out your notes, please.
I got a fresh new I have one for next semester, but so that's another thing. I think last 2 weeks I go through look at that. Page 1.
Yeah.
I couldn't tell if the second one was a V and it was like
Valve.
Wow. I mean, I can do that. It makes as much sense as value.
Yeah.
But
Average value, average height. It's like average Y value. I'm looking for here. Thanks.
it's good. It's okay. Exactly. I set my sleep schedule.
Second day being hard. Yeah. This morning I was okay. Tomorrow I'll do it.
Great.
Yeah, I-
Good sign. Yeah, but tomorrow I'm yesterday, so I'm going to Nancy Chrissy's family to take videos.
Alright, so we're going to look at average value, which is really just a formula. I'm going to show you like where it comes from, hopefully you understand it, hopefully I'll help you remember it. So, every rectangle is base times height, right? So the shapes we're finding the areas of are not necessarily rectangles, but the idea is if we took this shape and made it a rectangle, how tall would it be? So I'm going to kind of try to show you where that comes from. So let's just say area equals base times height. And I know that the shapes aren't rectangles, but the idea is that we're pretending, okay, what if they were? And then if I solve this for height, this would be area divided by base equals height. Well, how do I find area? Like if I give you a shape in general, say find the area of this shape, what do you do? No, go back to calculus. Derivative or integral? Wow, that's been a long time. Derivative finds slope. Integral finds area. So, the height is the integral divided by the base. So what we're getting at here is something like if I have a shape that looks like that, you know, that might be my A and my B. Well, that's a goofy shape, right? Well, the average value we'll find is, you know, the height starts here and it goes up and loops. The average value we'll find if there was a flat top. What is that height that would have the exact same area? What's the average Y value throughout this range? So if, let's say this area is 20, if I were to make a rectangle that has the exact same area, what is the height of that rectangle? That's what we're looking for. So take that goofy shape that we have turned into a rectangle, and how tall is that rectangle? That's what we're trying to find. It's the average height. So it's average value, average height. You'll see that kind of both ways. And it's always the integral divided by the base. So that's a formula you should memorize. I'll write on the board, but it wouldn't be there for like a test or something. I'll put it up there. So average value. So it's average y value. I don't write it that way, but average value equals the integral divided by the base. And what you're finding is the average y value. This is a good kind of thing to come back to because it'll review like how to actually solve it. I know it's been last year we did all that stuff. So let's say I gave you y equals x squared between 0 and 2. So those are both x values. So x squared between 0 and 2. So something like this. The y value of the very top of before. Now I want to find the average height. So this height obviously changes a lot from the beginning to the end. What's the average? Like this container holds a bunch of water, but it's a weird shape. That's another way to think about it. If the container was going to be just a box, how tall would I make the box? So somewhere in here, is the y value where the area of this red rectangle and the area of the blue shape would be the exact same. So we're looking for that height. So the average value equals the integral divided by the length, or divided by the base. What a lot of people will do is do 1 over the base times the integral. It's the same idea. So I'm going to go 1/2 times the integral from 0 to 2 of x squared. And so where do I get the 1/2 from? It's like 2 units long, so I can either divide the whole thing by 2 or multiply by half. This is like less. Like when you divide by 2, it takes up more space. So I think a lot of people just like to take up less space and go with a half. Questions on where I'm getting that part so far? Okay, so let's solve it then. So the 1/2 stays out here. Let's see if you guys want to solve the integral. So what's the integral of x squared? That's the derivative. 2x is the derivative. 1/3 x to the third. Add 1 to the power. Multiply by the reciprocal of the new power. Rough couple of weeks. So then you plug in the top, right? Minus plug in the bottom, which in this case is just 0, so that's kind of nice. So what's 2 cubed? 8. 1/3 of 8 would be 8/3. That's 0. So what's 1/2 times 8/3? 8/6. So 1 times 8. 2 times 3. So this would be 8/6. Or reduce it to 4/3 if you want. And that's the height right here. So if I took this red rectangle with a base of 2 and a height of 4/3, it has the exact same area as this, weird blue shape. So that's what you're trying to find. What's the average height that would give you that exact same area? And then, so is this a y value or an x value? It's a y value. Average value is a y value. That's a y value. What they'll ask you then is where does f of x have this value? So basically we're looking for this point here. What's the x value there? So the function is going to intersect that average value at some point. And they're saying, okay, where is that? So you take the original function, you set it equal to the average value, and you solve. Some of these are easier to solve than others. None of them are too bad. So I would square root both sides here. That would give me 2 over the square root of 3. Because square rooting 4 gives you 2. Square rooting 3 gives you square root of 3. Which I'm totally fine with as an answer. The AP test would probably rationalize it. And they'd be okay with it too on the short answer part. But in the multiple choice, they would probably put that. So that's this value right there. So there's 2 things you should be able to do. Find the average value, and then tell me where the function has that value. Find the average value is this formula. Do the integral and divide by the length of the base, or multiply by 1 over that. Work all that out. And then where does the function have that value? So you set the function, original function, equal to our average. That's all. Question on that? Alright, let's do, this is the first one on the worksheet I'm going to hand you actually, just to get you started on it. Do you want that first? That's the first one, right? That was sense. Thank you. Alright, so find the average value. I'm going to do like 1 over the base times the integral. Exact same thing as integral over base. I guess it's just easier to write the formula this way. It's easier to do the math that way. So it doesn't matter which you use, it's the same thing. So what's the base in this case? How big is the base of our rectangle, or base of our rectangular shape or whatever? 4, right? So we're going from -1 to 3. So 1/4 times the integral from -1 to 3, 2x. These are typically not like really difficult integrals. It's more like you understand the concept here. Let me give you a semi-reasonable integral to work with to make sure you can show me you can use the concept. So what's the integral of 2x? X squared from -1 to 3. So plug in -3, plug in +3, minus plug in -1. So she get 2. Right, you guys getting 2? I'm going to sketch a graph, and you don't have to do this. Just kind of see if I can help you understand it. What does y equals 2x look like? If I graph it, I'm afraid to ask this question. Oh, what?
It's a lie. It's
a lie. What did you say?
I said it's a lie.
So it's what kind of line? What's it straight? Horizontal, vertical, or diagonal? Diagonal. Sloping up or sloping down? Up. Slope is 2. What's the y-intercept? 0. So this is y equals 2x. Going from -1 to 3. So we got this here. What we just said was the average value. So this would be 6 way up there. This would be -2. We just said the average value is 2. So right in the middle. If I made a rectangle there, it would have the same area as if I took those two triangles and combined those two. So the next step, they would say, okay, where does that happen? So where does f of x reach that value? And so we're looking for, so this is 2, we're looking for this x value right here. I don't know if I drew it right, but I think it's over there somewhere. Yeah, it's right there. And so again, usually these are not like super involved algebra, they're just kind of making sure you know how to do the concept. So what two things am I setting equal to each other here? Rational equation of the average value. So in this case, it's just 2x equals 2. So that happens at x equals 1, which makes some sense based on the way we drew it. So that right there would be 1 comma what? That point. 1 comma 2. Questions on that one anywhere? Yep.
On the sheet, it says find the values of C that satisfy the mean value theorem for integrals.
That's that.
Okay. That's what I thought.
Yeah. Mean value theorem is like it's way more complicated than it seems. So let's talk about it for a second. If I start here, if I start at a y value down here, and I end up at a y value up there, do I have to cross through every y value along the way? Like if my y value down here is -2 and up here is 6, at some point do I have to hit y equals 3? Or you can't, it's continuous, differential. You can't pick up your pen or anything. Do I have to hit y equals 3? Do I have to hit y equals 2? Do I have to hit y equals 0? You know, if I'm born 3 feet tall, it's a little ridiculous, but just bear with me. And now I'm 6 feet tall. At some point, was I 4'1"? Yes. Was I 4'2"? Was I 4? You know, you're getting every point along the way. That's all the mean value there says. And you're finding the value that like proves it. All right. Questions on anything on that? All right. So keep. You got time to work on it. Maybe answer questions. Answer your resume. We'll move forward tomorrow.